Okay, so now that we've looked at the graph of e to the x and its derivative, let's explore its cousin. Let's look at 2 to the x. Okay, so if we remember, e is a value pretty close to 2. It's like 2.7 something. But it's always good to take a look at more than just one example. So if we take a look at this graph, it does, oh man, I'm going to get used to that. It does have a lot of similarities with e to the x. We know it still crosses through 0, 1. We can see that as we go to the left, it is getting less steep. And as we go to the right, it's getting very steep, but that the slopes are always positive and increasing. So chances are, in my opinion, its derivative should also look like its own graph. So let's test that theory. Really hopeful here. And this is where we should feel kind of nervous, right? So how is it that when we look at the derivative of e to the x, which is a number very close to 2, that it is its own derivative, yet when we look at 2 to the x, it is not just its own derivative. It looks like it's itself, but maybe compressed. Just we shrunk it vertically a little bit. So there's something more going on here, and that's what we're going to investigate in our examples.